Hi guys, welcome to that series of video about the new features of Golem 6. In this video I will introduce two new features, which is the population tool emitter attributes as well as the kill behavior. So I'm running Golem 6.1, but you could use Golem 6 as well, it doesn't make any difference. This is where we should end it up with. So that's a simulation where I emit a couple of characters from above the ground. They slow down, collide with the environments. Looks like kind of a ragdoll river. And as soon as they go out of the geometry, they get removed. So the way we remove those characters is using the kill behavior. So this is when the characters first arrive here. You may see that they get removed from the simulation. So the kill behavior can be like super handy to remove characters whenever you don't need them into the sim and get back some performances on the simulation side. And the population tool emitter attributes, which is the thing you're seeing from here, can be also super handy to add new characters whenever you need some. So I can actually show you how does the population tool look like. So here's the population tool, it's here, and it's emitting characters during the whole duration of the simulation. So let's start fresh and maybe let's clean the scene and remove all the golem nodes which are here. So to do this, you may have noticed that you can use actually the Golem Swiss knife tool. It's that tool there. It has a clean scene button here, so I can press it. It warns me that I'm able to remove all the golem nodes. So do I want to proceed with this? And sure, I do. And as soon as I do that, that's just delete every node which is related to Golem within the scene. So now I can start fresh. Sorry about that. I can also remove like all the lighting options just to be more interactive within the viewport and start fresh. So whenever I want to start a new Golem simulation, usually the first thing I like to do is to create entity type. So the entity type is asking me to load a character file, so I'm gonna go into my Golem character pack 6, go into Golem characters, and go for the casual man underscore light character. It's also asking me to load the shader file, so I'm gonna go into once again assets, Golem 6, Golem shaders in here. As I'm gonna use Arnold, I'm gonna go for casual man light. Arnold file. So I'm gonna select that guy, that file here, and open it. That's gonna create within the middle of the scene an holder for my character. So I'm just gonna select that character holder here and hide it for now because I don't need it within the simulation. Okay, good. Once my entity type has been created, now I can create my population tool to place my characters. So I'm just gonna create like go into the tool settings. I'm just going to create like a create population tool. So if you used that tool before, you know that that guy has got all the controls to specify where are going to be the slots of where the character is going to be generated. And before Golem 6, when you pressed create on that tool, that was just creating a new particle system with those 60 particles within it, and every particle will be placed where those slots were. Now within Golem 6, we may have new attributes which are called emitter attribute, and as soon as you're going to provide a value here, every time you're going to press create, that's going to create an empty particle system in which the pop tool will emit new particle. So let's try this. Let's say here with that simulation we'd like to emit up to 500 characters, and we're going to stay with the rate at 1 particle per second. Now if I press create, I can have a look at the new particle system which has been created, and you can check that that guy here has a count of particle which is 0. And now if I run the sim, I'll have like every second or so characters popping on random slots within the population tool positions. And maybe to get something closer to what I'm looking for, I can increase the rate to something like 20. And now you get like 20 characters being emitted per second, And as soon as every slot will be populated, you will have more and more characters on the same slot appearing. So that's why you can see all those characters popping at the same position. So that's the new emitters attribute. Just a side note, the emitter rate here can be keyframed. It's one of the attributes we're in Golem, which can be keyframed and which will be read dynamically. So that's a good thing to remember if you want to change that rate during the simulation here. So okay, I'm pretty good with this. Maybe what I want to do is to actually change the position of the portal so it's at a more convenient place. I'm gonna just rewind the sim a bit, and I'm gonna put it like here. Maybe I should change to top view so I can get a better idea of what I'm gonna do here. Maybe change the orientation of my tool a bit, and be good. Make it like a wider grid, change the distance between characters. Maybe I'm going to break that connection as well so I can independently change the distance here and noise that a bit. Put that on top of my plane and should be pretty good. Okay, so it means that now as soon as I'm going to emit my characters, I will have characters popping on the slots. So okay, pretty convenient. As you may notice, the characters here, they stay on the slot. We haven't provided any behavior, so that's why they just stay T-pose where they've been emitted. So now it's up to us to decide what do we need to do with those guys. So I'm gonna create new behaviors for those characters. So I'm gonna open the behavior editor, double click on my entity type for my casual man character. I'm ended up with my simulation graph here, in which I can drag and drop some behaviors. So obviously the first behavior I would like to drop here will be like a physicalized behavior. I would like my characters to be turned into a ragdoll or something more advanced as ragdoll, which will be servo ragdoll. What I want to do is I want to trigger this as soon as the simulation starts. So I'm going to change the stop trigger here. So I'm going to double click on that guy here. That's going to open my trigger editor. And I would like to do is maybe change the default value of my stopping trigger. I'm going to change it for true. So this is like the Boolean trigger. Let's just return either always false or true. So I'm going to check true here. So that means that when simulation is going to start, my physicalized behavior just going to change the status of my characters and switch them to dynamic rigid body. So if I have a try with this, I'll get my characters falling down. So they're going through the environment for now. So we may turn on wireframes first. So they are turned as ragdolls, and as soon as the ragdolls hit the ground, they just collapse following the joint limits information you provided to those characters. So they're in collision with each other and in collision with the ground. But obviously, with ragdolls, you don't get like a really proper result. So what we like to use instead is what we call local servo. So the local servo allows you to play an animation clip, and that animation clip will be combined with some physics simulation. So we're going to respect collision with environment and with the other character, but that means that you need to play at the same time a collision clip. So conveniently here, I would love to play like a maybe a full animation, but well, I don't have such an animation, so I'm going to play some random stuff I'm having here into my character pack. So as I said, I would like to play at the same time a motion clip, so that will be played as a local servo. And by the way, if I just play it like this, I'm just having my T-pose character, and they're just keeping their posture and bounce and collide with the environment or with the other characters. So yeah, really here I would like to provide a different animation so I get a proper result. So I'm just to play a motion clip, I'm just gonna use like a motion behavior. I'm going to drop it at the same position than the physicalized behavior. So they're going to be played at the same time. And within that motion behavior here, I'm going to load a couple of clips. So once again, I don't have any falling animation for now. So I'm just going to stick with some of the default animation which are provided within the character pack of Golem. So if I go into the character pack Golem motion audience, which are supposed to be the stadium animation, I can just load a couple of animations. So I'm gonna go for the sit watching one, sit watching two, and maybe stand watching. And if I select them all and press open here, they're all gonna be connected to my motion behavior, and they're gonna be like assigned randomly on top of my character. So a third of them will get that motion, a third of them will get another motion, and the last third of them will get that stand animation. And if now I play my sim, now you can see some characters are playing the sit watching animation or the stand watching animation, and there they're just falling on the ground. So maybe something which would be more convenient is make them collide with the environment. So here my characters, they're not aware about those Maya meshes here, so I would like to turn all those Maya meshes as Golem colliders. So I'm gonna select my environment meshes here. Make sure you select the actual geometry meshes, and I'll click on that button here, which is gonna create for each selected node a crowd rigid body node. So click on this, and if we take a look at the aligner, now we get those 12 new nodes, which are gonna be, I'm gonna group them. I'm gonna rename that GLM colliders, and those nodes will be the the rigid body version of my geometries. I would like to fix a couple of stuff. You may notice here that my geometry has its non-regular meshes. The creation process of the crowd rigid body nodes detected that those guys gonna be approximated as bugs. So that one is actually is not correct. No, it's not correct. The shape is not correct. So what I would like to do is maybe use another detection mode. So here that one has been detected as triangle mesh. So those modes here are not really, they're not really efficient for collision detection and efficient collision detection and precise collision detection. So what I would like to use instead is the convex hull detection. So you can see that here. Let's go back to wireframe so we can see what happened. And let's select that guy. So if I go from, which one is it? I'm not sure. Pretty sure that's that one here. If I go from triangle mesh here to convex hull, so you can see it follows the convex shape of the mesh here, and that's going to provide a more stable collision surface with the characters. So what I would like to do is change this attribute on my 12 different nodes, and maybe to get faster. So what I want to change is the shape type. I want to specify it's going to be value of 3. So once again, I can jump into the Swiss knife here, and you can see there's a custom operation panel. So that guy allows you to automatize any change of attribute on the plenty of different nodes. So you can start selecting the node you'd like to edit. So you can check, okay, this is the crowd rigid body node I like to change. The attribute I'm looking for is actually the shape type. And what I would like to provide is a value of 3. And if I press apply, that's going to be applied on either the selection of that node, and if my selection is empty, it's going to be applied on every single node of that type. So if I press apply here, you may have noticed that the display has kind of changed within the environment. Oh, so maybe I need to select them all and press apply. Oh. And check out what went. So if I go in that guy here, okay, that's a convex hull. So I'm pretty sure that works at the first time I pressed it. It's just that this display wasn't updated. So okay, now you can see that all my different nodes, they are set up as convex hull. So now the collision shape for those will be more accurate. I can switch back to shaded display and check what's going on in terms of collision. So that's better. They now collide with the environment and bounce on it as well. And they just fall. So that's pretty good. Let's increase the frames here. So what we'd like to do maybe is also have a faster emission rate for the population tool. So what we'd like to do is maybe change that value here and say what I want is 100 characters per second. So that means in 5 seconds I will reach the emission rate. And okay, now it's better. I'm having like a better density of characters being emitted. Okay, so what if I want those characters to flow down that geometry? To do so, I can use another behavior which is called the force behavior. So that's that guy here. That force behavior allows to apply a force on the physicalized character. So we physicalize the character, turn it into a servo controlled ragdoll, and next we're going to apply a force to that character. So there's two different force I can apply. One is an impulse. So impulse can be the force you get from an explosion. So that's something which happens just during one frame at a specific moment. Or you can apply a constant force. So the same force will be applied on the character during the whole duration that behavior will be enabled. So the direction in which I'd like to apply that force will be along the x-axis here. My character is going to be emitted from here. I want them to flow down along the x-axis. So I'm going to specify a direction of 1, 0, 0. And I want to specify what's going to be the magnitude of that force. And I'm going to say it's going to be something like 25 maybe. I can actually noise this a bit. So it will get here if I put a value of 3, it means that my characters will have a random magnitude between 25 and 28. So let's take a look at how it goes. So I have my characters now flowing down. Okay, it's maybe a bit too fast. And they're actually flying. You can actually see that before they fall, they start to be they start to be influenced by that force, and they don't even have the time to fall down against the floor. So what I may want to do is maybe get a slight lower value here, like between 17 and 20, and we should be good. But still, they are still influenced by the force before they actually hit the ground. So what I would like to do is maybe give them a pause between the time between the time they are emitted and the time they touch the ground. So I can come with a block operator. If I put that block operator in between my behavior, I can block the signal. So as soon as the physicalize happens, then my characters will fall, be influenced by the gravity and the collision. Then before I jump to the force behavior, I want to block the signal for a couple of frames. So let's give them between 20 and 25 frame to actually fall. So okay, that's a bit better. So now they fall, and as soon as they wait for 20 or 25 frames, they're going to be influenced by that force, and they flow down, collide with the environment, and as soon as they get out, they just should collide with the default ground, which is here. So that's what's happening here. Okay, good enough. Last step for my sim is to delete those characters as soon as they get out the geo there. So here I'd like to introduce the kill behavior. So that kill behavior will be coming right after my block here. So this is my block controlling my animation and my physicalize, and I'd like to add a kill behavior. So the kill behavior is pretty simple. It doesn't have any attribute. That's just remove the characters from the sim. Please note that as soon as the characters has been removed, you can't bring that character in anymore in the sim. If you are gonna emit characters here, so you can use also the emit behaviors. There's a tutorial which covers this as well. If you're going to use the emit behaviors, it's going to emit new entities which didn't exist previously in the sim. So as soon as the character is killed, it's killed forever. So now I'd like to trigger that kill behavior. I want to go into that kill behavior as soon as I get out of the geo. So I'd like to create maybe like a geometry there, like a cube box. Put it here. Maybe let's rescale that guy a bit. Oops, and into mostly that direction and that size there. So this is going to be the zone in which as soon as my character is going to reach and will be into that zone, there will be like removed from the sim. Maybe I can just assign like a different material and change the transparency so we can see what's going on here. And what I'd like to do is use a trigger zone there. So ideally, what I want to do is stop that block there as soon as my characters get into that box. So to exit that block, what I can do is go into either one of the final stopping trigger of this branch here or that branch there. So I'm going to go for the motion one. And I'm going to say the trigger, which is going to be, stopping that behavior, will be like a zone trigger. So instead of using the false trigger here, I'm going to use the zone trigger. I'm going to right click on it and set it as root. So now it becomes the active trigger. And I want to connect that zone trigger here to my polygon geometry. So I'm going to select my polygon geometry, press shift, select my trigger zone, map the two together. So I want to check it as a 3D zone. So I want to check if I'm inside the volume of the geometry, and that's gonna stop that motion behavior as soon as it gets in the box, which is not gonna be good enough for now to kill the character. So if I put my characters here, you will see that just my character is gonna be emitted as soon as they get into this. They don't play. You may see here that they don't play the motion anymore. They back to T-pose. So this is here the characters which are playing an animation, and as soon as, let's click on that guy here. So as soon as it goes into the zone, you should see that that motion behavior here should stop. So there's some stopping duration to make a transition to a T-pose, and now the character is back to the T-pose. So that's not good enough. The character is not killed yet. Because as you can see, there are still some behaviors running. There's still a forced behavior and a physicalized behavior, which are stopping the signal and which are making it staying into that parallel operator. So what if I want that any of those branches here triggers the stop of that parallel operator? I just have to click on the parallel operator. I can go into this attribute and I can check what's the exit mode for that parallel operator. So right now it says that it's going to exit as soon as all the behaviors have ended within that parallel behavior operator. So you can see there are still some behaviors running, so that's why it doesn't exist. It doesn't exit yet. So what I can do is I can say as soon as one behavior is ended, which means as soon as one of those branch ends, that's gonna like stop the other branches, or I can like specifically say which behavior you should monitor. So here the one I'm gonna monitor is the motion behavior. So now it means that as soon as my characters will go into the box, the motion will stop and the physicalize will stop as well. So if I click back on one of the characters here, so is running the physicalize and the motion behavior, but as soon as it's going to reach the box, it's going to stop the parallel operator and it's going to play the kill behavior. And voila. So, just to make it more convenient and more fancy, put that box there, we throw the sim, and that should be good. So I've got my characters flowing down, colliding on the environment, and as soon as they get into the box, they actually disappear, which means that when everybody will be removed, I would have like a peak of performances. Right now I'm running at 5, but if I run until the end, you can see that the frame rate is actually starting to catch up until going back to 50, and all my characters have been deleted. So that's all for that tutorial. Hope you liked it, and see you in the next video.